Hey guys, and welcome back to the channel. I have probably a short video. This is coming from Virginia. It's a Maybe 4 Marine ECM. It's an 8.1 liters. I don't have much description, so that's all I can give you. Let me move you over to the connections so you can see I have, and the computer was open, I think, by the customer because you'll see my notes. So his name is Brian Finkel from Virginia, and he's been here a couple of days. Part number on the computer is 12569494. The very unique numbers are letter A, 2253. Let me see. Yeah, 22530345. All right, so his concerns, we'll see in a second. Let me make sure I have it ready here. All right, that's a picture that I always take with the computer connected so we can see everything in his note. Let me get you a little closer on the entire page. I removed obviously his address and contact information. He's from Hartfield, Virginia. And he had in the note in there, I didn't know what EVDC means. Output, no EVDC output, no tach output. Engine runs properly with ECM and the part number that I just told you in there. It's an 8.1 liter. So I call him. It's like, Brian, can you please explain me what EVDC means? And this is the diagnostic port. So usually it's called DLC or so, but that is fine. All right, so you can see the concerns in here. No diagnostics or no communication, and then no output. Engine runs properly. So we have no drivability concerns, just no tach and no communication. So we're going to, since I have the computer running, right? So let me move you back to here. And let me get the picoscope and the diagram in the capture. I'm going to just select, actually I need to connect first. And let me actually disconnect and reconnect so you can guys see all that. So let me make sure that that is playing. Yes, okay. So we're going to do a selection of MEFI 124. This is a MEFI 4. And see if we have communication, which I know we have now. So it's mode 1 and right here. So we are connected to your computer, Brian. So there is absolutely no issues as far as the computer. So you might have a problem even on harness or the connector itself, or maybe the pins on the computer as far as the connector pins, not the actual computer. All right, so I'm going to just go by quickly on here. That is the calibration checksum 0212, which I don't have one, so I don't know exactly what this setup will be for. And we have now 8 fault codes, but those are just because I only have one coil connected. And since he has no problems, running condition problems, so we can disregard those. So, right? And I'm going to show you, let me go over to the codes page, and we can see it's all 41. The first one says ESC system has an open circuit, and then the rest ones are ESC H, G, F, E, D, C, and B. So the only one missing in there is coil A, or output A, which is in this case the one I'm using for the coil. So in here, let me just take this slide out so we can get a little darker. This slide right here, the flickers blue, is the coil activation, and then the 2 green ones next to it are both bank of injectors. So this computer has 8 coil drivers, but it has only 2 injector drivers. So these injectors is what we call batch fire. It will fire 4 injectors per driver. So every time one of those flickers will fire 4 injectors at the same time. Right now I have in the oscilloscope, which is the bottom view that you see there, 2 signals. One is the tachometer, which is his concern. The tachometer in these computers is in connector J1 pin 14. And we can see that in the red channel. We're going to get a little closer, but for now, let's just keep it in there. So let me keep going with what I was going to show you here. So I'm running, well, let's see. This computer has 560.2 hours. And I have right now the warning on and off. And obviously because we got those output disconnected. Throttle position of 6.6%. The manifold air pressure at 12.8. That's normally what I use here for my test. And finally, oh, before I go finally, again, just to show you that this engine displacement is an 8.1 liters, as we already know. And then finally, the RPMs. So we have no computer concerns as far as running, so I cannot really see anything wrong here, Brian. We do have the tachometer. I'm going to unplug the tachometer signal from my oscilloscope, so you can see that it's indeed connected to that. And then I'm going to connect it over to the other bank of injectors, which I have to change the voltage because it was for the tachometer. I can change also the speed. Give me 1 second. So I'm going to reduce the capture on the screen so we can get that signal to look at better or closer. I'm going to put a trigger, and the trigger, what we'll do, and I just move it in there so you guys can see it, is to stop the capture right there. Even though you can see a little bit of a movement, that's what the trigger does. We'll stop the signal. I'm going to move that same channel over to the coil activation so we can see the coil firing. And it's going to be one because I only have one coil, right? All right, going back to the tach. In this case, this is the tachometer signal, and that tachometer is very unique because it has a signature very close to what the crankshaft position sensor does. So whatever signal I'm producing in here, that's what the tach will use as per its own signal. So, but it's present. The amplitude of that waveform, we have around 2.8 volts, 3 volts. And that is what this computer uses. So I have no other one in here to actually test. Let me just think about that. Actually, I have another computer. Let me plug. I'm going to stop the video just because I have other MEFI4s in here. And I'm going to plug one of them to just see what the signal should look, even though they're not 8.1s. The tachometer signals should be very close to each other. So let me check that out and let you guys know. Actually, I'm going to do this with you guys on the video. Might as well, right? So you can see what we can see together. So I'm going to just turn this computer off. But before I do that, let me disconnect it from the scanner. And before I do that, well, remember the calibration on this one being 0212, and it's an 8.1 liters. The one I'm going to connect is a 5.7 liters. Yeah, let me I'll disconnect from there. I'm going to turn this off. All right, so that is now off. I'm going to disconnect the computer. Let me turn the power off in here just because when I have to change the signal, I'm actually using my auto simulator to have a nub. I'm not really happy with the design of that crankshaft position sensor signal with that simulator. I like the simulator a lot, but that is so hard to make it work. And I can't be doing that. So I decided to run a cable from my other simulator. Especially for these computers, I got no issue with that. So I'm going to keep Brian here. Either way, they're very different computers. So I'm going to plug these up. And just out of the screen, I'm going to change the signal from the 8.1 to the 5.7 so I can use it. So give me 1 second. I'm doing that behind the scenes. It's very quick. Right, make sure it's right in it and it's doing it. I have already presets that I have done, probably, I don't know, maybe 3,000 presets. All right, so that should be good to go. I'm gonna have to lower the speed because those are very different signals. So let me go over down to like 70 hertz or so. If I remember, it's around there. It's not running. All right, so we're good to go. Let me power that computer on. I need to turn my power supply on, right? All right, we can see the fuel pump coming on. And I'm going to reestablish communication the same way we did with Brian. So we got a good communication in the module as well. And now we're going to connect to this one. This one is a C4D4. This is from a customer in Washington that I still have here. And let me just show you that this is a 5.7 liters. but the tag signal and everything should be outputted on the same pin as their own FE4. They don't change that. So even these computers can run the 8.1 calibrations as well. So it's just a matter of calibrations, right? So, all right. So let's run it, right? So I'm gonna do that here. So I'm in 800 RPMs. You see, with this knob, I can control that really, really nicely. Well, I can definitely see a difference. Let me go over to the oscilloscope. Oh, I brought that down, which is not what I want to do. But yeah, we do have a very different amplitude, right? So this tachometer is actually 12 volts. Or what is that saying? Oh yeah, because I have the other one at 3 volts. But if I put it in here, so that line is 0, and the highest part is 12 volts. Almost battery voltage. And it has a very different signature. I'm not sure what to say. And this is the problem. I might not having an 8.1 right now because I might be chasing a rabbit hole. They're very different computers or different calibrations, and also computer, because this is a 1258 4052, which is a FE4B, and the other one is a FE4A. So they're very different hardware. And I'm not sure if what we see is a problem on his computer because the amplitude is very small compared to here, right? But I'm not sure because I have not really collected that. And since I don't know exactly what boat he's using, because definitely this is not a Volvo Penta. And not a Malibu or Immer, because I'm not sure if, what are we dealing with here? Is this for a car? So I'm going to have to contact Brian because I have a signal. I can see that I have a signal and I have communication. So maybe his problems are all harnessed, and I will be, like I said, just wasting my time trying to correct something that doesn't exist. And this is where it's important sometimes to just back off a little bit, even though, we can see that computer fully working and everything good in that one. And I'm very familiar with it, with the 5.7s. I know that, yeah, the amplitude on these ones are different. I'm actually looking for the signature to be different, but it's also the crankshaft position sensor signal on these two computers, 8.1 and 5.7, are completely different. That's why I have to go and change the signals. So yeah, it's not because I'm now doing a comparison with like a tomato and a potato. They're different, right? So I cannot do that. But yeah, the signals are in the same pin, but they're not the same amplitude. I think that I'm going to have to just do this as a test and get more information. If I have to do repairs, guys, I will probably be doing a part 2, so I don't have to be doing very long videos for you guys. I can show you connections, which I have also here, where I always, I get my information. I got manuals. I got everything for these computers. And let me show you that too. Let me move all this out of the screen and move you over to this. So this is I have folders because I got manuals. Like those are all manuals for all these computers. But I have also take pictures of the connectors, and I can show you here in J17, sorry, J114, not 7. J114 is the tachometer output, and that's exactly where we are. I have also made my own connections or, I don't know, pages with my marks and everything, where I mark everything, and we can see right here, J114 tachometer output 1. I have also a complete diagram where you can see, what I was telling you about the coils. So these are in here where I'm moving that red arrow, my pointer, the mouse pointer. These are all the coils outputs. And at the left, right here, when I'm moving right here, it says J114 tachometer driver instrument panel tachometer. All right, so it's the same output. If we move this or go over to a 5.0 or 5.7 diagram, you see there is a very different diagram. Why? Because it uses a distributor. So this does not use each, a coil for each. Actually, here, let me just see where the coil is, because that's not the coil right here. I thought it was that one in there for the distributor. No, so that's actually the vehicle speed sensor. So we can see right here the output for the coil ignition driver is in J132, which in the 8.1 is coil A or coil 1. But yeah, that's the only difference as far as the tachometer. We can see right here too, right here. I'm going to make that very big so you guys can see it. Tachometer driver, J114, same thing. So the tachometer doesn't change, but the amplitude of the waveform might change. So I'm going to have to decide. Let me see how much are we talking in here. 15 minutes. I can probably let me open the computer at least to see if I see something. There might be. And I say, oh, actually, I forgot. We have the computer open. So let me just do that. Let me take a quick pick, and I'll be right back, guys. All right, guys. Yeah, sadly, it's actually a non-replaceable component. So in this case, I checked the circuit from the pin all the way to the IC, and it's intact. So the problem has to be in if it's a problem. Because again, since I don't have a computer to compare to, and I have no idea what this is, I tried to call Brian, but no answer this time. It's already late. It's 7:32 p.m., so I don't blame him to not answer. Let me show you a picture of, this is my own pictures, my own information. So you will not find this anywhere else. But yeah, so I know exactly where the tach is. This is an IC. As you can see, it's a crystal-made IC. So let me get a closer view. So let me just show you here. So this is a crystal material, like crystal, because literally it breaks like crystal. And I have done, got a computer that is not repairable, keep it as a core and rip everything out and mapped out every single component, every single pad, so I know exactly where to go and everything. And this is just a little bit of information. I have more than this, and components and everything and where they are. But yeah, this component has 67 legs, so it's impossible to replace it and find something that you can install there, right? Because when they make these crystal components, they make pins under it, not like a normal or another component that is like a plastic or so. Usually the legs they can be underneath. There will be balls, like solder balls, or they have legs on the outside. This is like a mix of those. And the problem is it's very, very thin, nothing that you have ever seen before. This is a very unique EM because this is a Delphi computer. Just to show you what this is, so you can get a better idea of the entire, computer. But yeah, so not much I can do, sorry, Brian, on this case. I tested your computer and it's tested as far as communication good. As far as the tachometer, I will have to compare to another one, and I don't have. I will try to contact you tomorrow to see what setup you have. And then either way will be a non-replaceable and non-repairable, because the path from the pin, which is J114, all the way through there is intact. So there is not a broken in. If it's resistance, no, I check it, from there, from the pin all the way to that IC leg, and it's 0 ohm resistance. So there is no like a resistor or anything in place. So this is a direct line from there to there. So whatever is happening is either happening underneath or nothing is wrong and you just have a harness issue. Again, without knowing what your setup is, I cannot give you that answer yet. But I'm going to stop the video here. I think this is enough, guys, and I have to try to share as much as I can. If you have any marine or automotive computers for repair, I'm going to put my website name on the title of this video so you can copy and paste it in there. And when you go on the website, right in the center bottom, you have my address. On the left side of that, you will have a white box that says click here to fill this form. And on the right side, one that says click here to email us. Email me, please always email me. Like that I can get more information from you, and we can establish a line of communication. And then we go from there. But yeah, please fill the form with all the information required in there and sign it. Very important that you sign the repair form and that you are approving me to test. Otherwise, I will have to get approval over, an email or something where you say I approve the repairs or the test, and I can proceed. But it's better if you do that, like that is no delays when your computer gets here. And if you're here in my channel, please subscribe to the channel. It's for free, and if you do so, I would really appreciate it. Every time you subscribe to the channel, YouTube promotes my videos more and more, and that's how you find me. So thank you so much if you do so. I'll see you guys next time. Good night. Bye-bye.